All right, so the last equation that we're going to solve, again, there's a lot going on. We just have to make a decision about what base do we want to write it in, because if we can figure out what base, we'll use some exponential rules and we'll be able to cut to the chase. So right now I have a base 8, a base 2, and a base 32. All right, so what seems to be a common base between them all? All right, well, if you think about 8 itself, right, we know that 8 is 2 to the third. And then even 32, we know that 32 is 2 to the fifth. So since I can rewrite 8 in base 2, and I can rewrite 32 in base 2, what we want to do is keep that base 2. So this one's going to stay the way it is. It's already base 2. This one, be careful how you write it, right? Because 8 is 2 to the third power, but we're raising it to the x power, right? So that'd be another way to write 8 to the x power. And then 32, well, we saw that that's 2 to the fifth, but it's being raised to the x power, right? So good news, right now we have everything, the base is the same, but we don't quite need what we need, because we need to clean this up, right? That way we know exactly what powers to match to what powers. Okay, so first exponential rule is what happens when I take a power of a power. Well, in that condition, what we're doing is we are multiplying exponents. So this becomes 2 to the 5x, this becomes 2 to the 3x, and then we're multiplying to 2 to the x plus 1. All right, so that's the good old, right? If we take a power of a power, the rule is to multiply the exponents, right? In the next one, right, I have the same base and I'm multiplying, right? So if I have a to the n and a to the m, right, the rule is we keep that base and we add the exponents. So in this case, we're going to keep the base and we're going to add the exponents, right? Maybe I'll use parentheses so you can see that. Over here, there's nothing else going on. So those are the two rules we have to remember. Also remember, it didn't come up, but if we're dividing, right, we subtract the bases. So I think you'll see some of those. So there's your rules that you got to remember essentially in your homework. So basically, finishing this off, we have 2, 3x plus x is 4x plus 1. And then on this side, we have 2 to the 5x. So finally, right, after using some exponential rules, using some exponential ideas, figuring out what base to write everything in, I now have something useful, right? My base on both sides is 2, and we're claiming that they're equal. So what has to happen? Their powers have to be equal. And if we subtract 4x from both sides, right, what we end up getting is that 1 is equal to x. So pretty simple solution there to begin with. So there's the challenge for that one. If we already have, again, if we saw it earlier, if we already have the bases the same, we can cut to the chase. If I don't have the bases the same, I try everything I can to get it into that form. Sometimes it's easy, and then sometimes it's a little complicated, and you're going to have to remember your exponential rules and let them come into play and help you out. All right, and as usual, as they say, math builds on itself. So don't forget what we've learned or what we've used in the past. Right, so that wraps up section 6.3. So we've introduced ourselves to a very important basic function we can add on to our list. Right, we have we almost had like a dozen of them, and now we have 2 more. Right, growth models and exponential decay models. So there's our new models, and we're going to continue, right, to build new functions and solve new types of equations and do new applications in the future. If you have questions, please come visit me during an office hour. Shoot me an email, and we can maybe discuss it there. Or you guys can basically talk about it on Canvas. Post your questions on Canvas. Give myself and your classmates an opportunity to give you some corrections. You guys keep doing well. Good luck on the quiz. I'll talk to you later.